The previous lecture we looked at the mailbox processor and saw how that could help with managing state using the actor model. And in this lecture we're going to look at a very important invention, which is the ModelViewUpdate pattern, which puts the mailbox processor to work really properly. But at first I think it could be in its place to have a little historical sort of refresher back view on what this is and where this came from. So the whole thing goes back to something called functional reactive programming, where in the late 90s, Paul Hudak and Cornel Elliott were thinking about how to do computer graphics in an interactive, responsive computer graphics in a purely functional setting. Haskell had just been invented, and both Hudak and Elliott were involved in that process, and they wanted to be able to do computer graphics. And then they came up with this idea of functional reactive programming, which is based around events. Things happen, and then they have what they used to call behaviors, and then later were called signals, and were given a sort of a signal processing analogy of how those events or those signals then progress and get transformed. Now, functional reactive programming is it's very flexible, and it's very general, and there's a whole deep theory behind it, and it's very sort of formalized. The problem is that it has a fairly high mental overload, which makes it sort of not so easy to learn, and actually somewhat tricky to program also. But that was sort of the way to, and still is in some respects, the way to do really reactive programming in a purely functional setting. Now, then in 2012, Evan Czaplicki was a PhD student, and he was interested in functional programming. He was interested in programming languages, and he was interested in particularly in functional reactive programming and for the web. And he was thinking about these things, and he came up with some ideas of how he could make functional reactive programming easier to learn. So he created this toy little language which he called Elm, which was targeted just for the web, and writing, instead of writing JavaScript, you would write Elm, and he had this functional reactive programming approach to it. Elm had no I/O whatsoever. Everything was happening in a pure functional setting, and any I/O that happened in the background. Now, so Elm came out in version 0, 1, and 2, and so on, and every time a new version incarnation of this Elm language came out, he had come up with a new idea how to make it sort of more easy to learn and simpler, and suddenly he had tossed out the whole signal event scheme altogether, and he had ended up with something which is now known as the ModelViewUpdate, which is sort of related to functional reactive programming, but it's not really. It's a different thing, and it's sort of much more actor based. Now, Phil Freeman, who is the guy who created PureScript and a mathematician, he actually sometime later he did a category theory analysis of all these things, and he could show exactly where on the mathematical map where these various incarnations of functional reactive and the MVU belonged. So there's, just so that you know, there's a nice theory behind all of this stuff, and everything is mathematically sound. So let's first start with a really simple MVU pattern in its absolutely simplest form. And the way this works is very, very clever, and it's very, very simple, and it requires absolutely no mutable state whatsoever. At least not in sort of our hands as programmers. we'll see that the view part, of course, since it's going to view something, it's going to do some I/O. So there we need some kind of things, but we put that in the hands of somebody else. So the way this works is that you start out, we have a model, which is just our state. It's just data. You can think of it that it's just a record type or a record of records or tuples, or it might be a string, whatever. And that model is then fed into a view function, which is something that will render it, view it, do the interaction with the user. And typically this view thing is so it could be something that shows a web page on your browser, but it could be something whatever. It doesn't have to do anything with the web. But that view thing will then somehow interact with the user. So you click on something or some event happens, and the view will then dispatch a message which goes to the update function. And the update function will receive that message. It will look at the message and say, okay, what kind of message is this? It will extract any kind of data from the message, and it will create the new model, and it will send it back around in the loop. Now, if you think about this, this is quite similar to what we looked at in the previous lecture with the mailbox processor, where we had this internal event loop which received the state, created a new state, and sent it back recursively. So this is sort of the same loop going on here. Now the view, it will receive the model and it will receive a dispatch function so that it can dispatch to the update function. Now this dispatch function, turns out that if we use a mailbox processor, is nothing else but post. So it will post the message, it returns unit, it posts it off and returns asynchronously. So this is the whole idea, and this is really the essence of the MVU pattern. Now it turns out that this, if you just do it the really simple way, it's not quite enough to do really general things, or it becomes really cumbersome. So there's a little update to it. So here you can see you have the original MVU thing. The update updates the state, it gets rendered, the view thing will then interact with the user and send off a new message that goes into the update. Now what the update will have the possibility to do in this incarnation of this thing is, instead of just updating the model, it can also create a command. A command is just a wrapper around a message. And all this goes into the Elm runtime, and then it will say, oh, there's a new message. So it goes into the update, and it might update looks at the message and says, okay, what's going on here? It finds out that it should do something more, sends a new command, and it can go in a number of times through this loop before it then updates the model and sends it to the view, and we get the new event from the user, and which could be a click or a mouse move or something, whatever, hover, who knows. It goes into update and we repeat the whole thing. So we can look at these things. So the model is just the state. The view function is something which receives the model. It receives this dispatch function, which is just the mailbox processor post in disguise, and it returns unit. So this thing here is sort of impure. It will do some I/O. And the update function is a pure function. It receives a message, it receives the current state, and it will produce a tuple consisting of a new updated state and possibly a new message in a bottle, which we call command. We'll look at these things in a short while and see how that looks. Right, so when I tell you that this is really simple, I actually here's a slightly somewhat simplified version of a full real working runtime for this MVU model. This is it. If you go back to the F# Fable Elmish original implementation of the whole MVU thing, everything you need to do interactive, responsive, web applications, I think the complete implementation is 200 lines. So that's actually how simple this is. Of course, it's relying on the mailbox processor and things like that, but that's which is a little bit more. But you can even implement the mailbox processor in like 50 lines, so it's no big deal. So so this is how it looks. We define a function, we call it run. It takes a model, it takes a view, which is model is just some data. View is this view function, and then it takes an update function. And then we create a mailbox processor, we start it, it gets an inbox. Internally we create an infinite loop, which contains the state. And then it will receive a message, and then it will call the update function with the message and the current state. And the update will return a tuple consisting of a new updated state and some commands, or a single command. We give the new updated model to the view function, and then the dispatch function is just this post thing, so that the view can post new messages into this mailbox processor loop. And then after that, we take the command, the new command thing, which is a list of messages, and we just post them one after another. We post them back into this loop, and then we loop with the new state. And that's it. So simple. It's almost unbelievable. And if you're going to look at proper functional reactive programming implementations, they're not this simple. I can promise you that. They are quite involved. So, all right. So there's one little piece missing. So sometimes you want to have the possibility of setting up timers or listening to things coming in on WebSockets, or you want external things that can happen that are outside of the control of the user. Because inside the view function, it's the user who is interacting with the system, clicking on things, hovering, moving the mouse, doing all these things, which is generating these events, which gets dispatched to the update, and then model up and so on. And so in order to have these external events come in, you can add subscriptions, which is just a way of generating and sending in new commands into the runtime, which will then go to the update, which might just update the model, or it might go back and send in a new message, and so on, and we can go around in this loop in various ways. But this is just a slight complication. It's no big deal. You can read about it in the documentation. It's just the same story, really, all over. Before we go and look at an example of how this works, I just want to make a small advertisement for Fable Reaction. This is my new favorite toy. This is again a variation on a theme. It's very closely related to the MVU, but it takes a slightly different approach. So this library here is due to Doug Bratley, who used to work in my group, and he had worked at Microsoft previously and been involved in reactive extensions, which is both a JavaScript and a Python library for doing pretty advanced reactive programming. Now, this is very similar to the MVU, except that your update function can only update the model. It cannot anymore send any new commands or messages or anything back into the loop. So the way this works is that you have a model, and you got some messages, and the messages don't get sent now to the update. They get sent to a stream function. And the difference here to the stream function to the normal update is that the stream function is working on these asynchronous observables, which is a sort of a way of doing stream processing. So this is a great way of handling, for example, if you move the mouse, it's going to generate enormous amounts of messages and a stream of messages, and you can just really easily transform them and work with them in a very natural and functional way inside the stream function. Now, the stream function will process all these messages. It cannot touch the model. It cannot update the state of the system, but it can do all kinds of things like call APIs, deal with mouse, subscribe to the mouse moves, subscribe to WebSockets. It can do all kinds of things which will generate all these messages. And then when it has done all the processing, it will send off some select subset of those messages, typically to the update function, which updates the model and which then again updates the view, and the view can then generate new messages, or it might be that the WebSocket generates messages and they go back in and you get this thing. And the reason I say talk about this is that this makes certain things a lot easier than in the traditional MVU. Things like autocomplete, drag and drop, WebSocket handling, calling APIs in general becomes much cleaner in this approach. So it's a very nice way of doing things. It comes with a certain cognitive overload. It's not the simplest of libraries to understand, so it hasn't become super popular, I think, for that reason. It takes a little bit of effort to learn, but it's really worth it. All right, so let's have a look at some code. So what we're going to do here is we're going to actually implement a full MVU system from scratch. The only prefab thing that we're going to use is the mailbox processor. So the first thing that we want is just to define a general type. I'm going to call it command. This is strictly not necessary, but it will make life easier. And this is not quite how it's actually defined, so I have simplified things a little bit extra here. So the command is simply a list wrapper around messages. So a command is a list of messages. So that's it. I haven't said what the message is at all yet. I'm not saying that in my implementation. Then I'm going to create the record type just to wrap things nicely. Strictly not necessary either, but it's parameterized over the state. And again, this same message type that we haven't said what it is. And this is just a record type containing an init function, which is just to set up the initial model and perhaps send some initial commands. There's the update function, takes a message and a model and produces a pair of a model and a command, which is, again, might be just an empty list or something. And then there's the view, which takes the model, it takes this dispatch function and returns unit. So these are just a little bit of helper structures. Here's the runtime. This is pretty much exactly the same runtime I showed in the example, except that now I initialize this model here. I initialize the program with this runtime thing with this program instead of having the parameters init or model update and view explicitly, and then I call init to set up sort of an initial model and some initial messages to send into things. I have the mailbox processor. And then the event loop. Receive, update, call view, and then iterate over all commands that the update might have sent back and post them back into the system. Everything is wrapped around if there's an exception or something, and we can do some error handling. Not strictly very necessary. And then I just say, well, okay, now I started the event loop, and then I just take these initial commands that this init thing had and I post them. I just loop over this list and post them one after another into this mailbox loop. So let's have a look. Now, so this is it. This is a complete working albeit slightly primitive and not super flexible implementation of the MVU. So here I've done it in yeah, well, if we remove a little bit of this, I could have done it in 30 lines less, which I think is kind of impressive, really. Right, so let's create a model. So I'm going to have a super simple model. It's going to be a just consist of a simple thing, a field named sum, which is an integer, and it's going to have a message type, which is a union type, which has two types of messages: increment or decrement. So these are our sort of model data in a real web application. When you're doing things or using this MVU in things, these get much more involved, of course. And the model will be an image of the type of data that you're interested in, and you might have submodels and so on and so on and so on. And you will get a lot of messages. But for this example, we're going to keep it really simple. So we create a init function. It takes a unit and just returns a model and a command. So it will take this model type, set sum to 0, and then I will have a list of messages sent, and I say increment 0. Because I did things so in such a simple fashion, I actually have to send in this explicitly a starting command. Typically you wouldn't do that. You would just say send in a dummy command. But I simplified things a little bit. Now, so here's our update function. Takes a message and a model. Pattern matches on the message. Says, oh, is it an increment message? Yes. Print some debugging stuff here. Updates the model, sets sum to the previous value of sum, and adds the number. And if it's decrement, it will subtract the number. Now I'm going to put in a little helper here, since I'm not going to have any proper user interface or any sort of thing. Typically, most of these things in reality, when you're doing web programming, are relying on React.js in the background to sort of render things on the screen and do the sort of lifting and virtual DOMs and all the optimizations that you can do to get a nice smooth experience. Since we don't have anything like that, this is going to be a console application. I have made a little sort of event simulator. It receives the dispatch function, sets up a random number generator, generates two different random numbers between 10 and 0. Then it sleeps for x times 500 milliseconds, so up to 5 seconds. And then I asynchronously check whether x is greater than 4, since this is from 0 to 9. And if it is greater than 4, I will increment by this other random number, y. Otherwise, I will decrement by the number. So now I dispatch. Now remember, this dispatch is just the same thing as this mailbox processor post. So it just posts this thing into the mailbox processor. That's all it does. And then I start this thing asynchronously. The reason I do all of this asynchronously is then it will just send it away and we're happy. I actually don't even think it's, when I think about it, this is not really even necessary. I could have just skipped the async part, but well, I don't know what I was thinking. So let's create a view. The view gets the current state and the dispatch function, and in this case the view is just saying sum is, and then it prints the model sum, and it dispatches the next event. So every time view gets called, it will start this thing. Oh yeah, now I remember. Yeah. It will start this thing which will sleep and then dispatch a new signal, and it will go back in and around and around and around. So we can follow and see what's going on. And then finally, we put everything together. Created a function, run program. It takes this initial data structure, this record type with the init function, the update function, the view function, and pipe it into the runtime. And then I just say, okay, this thread can now sleep forever, because otherwise my program will exit. And now I want to keep my runtime running. So this thing here will keep on running until it exits, which it never does. So this will run until I terminate it. So let's save this thing and run it. So we're just going to take the whole thing here and send it into F# interactive. And let's see. I'll go make this larger. All right. So now I can say run program. And okay, so now this display unfortunately got a little bit garbled, but you can see here it says +0, sum is 0, +3, sum is 3, +2, sum is 5. Let's see how when it gets down a little bit further down here. This didn't handle the. So you can see this thing is running and it's injecting these sort of user events into the system at sort of somewhat random times. It's sort of clicking on something or doing things, and our fancy user interface is responding instantly with the updated state. So this is it. This is actually how simple the ModelViewUpdate thing is. Now let's see if we can stop this. So there we go. So this is sort of the basis for doing interactive web interfaces in F#. And in the next lecture, we're going to look a little bit at Fable, which is a F# to JavaScript compiler. And Fable comes with the Fable Elmish library, which is an implementation of this ModelViewUpdate. So everything is already there. There's also a Fable React component, which contains a complete HTML domain-specific language for generating HTML. And when putting these things together, we can make these fantastic reactive, interactive web applications. I have not really decided whether to use actually Fable Reaction or if I'm going to use a newer library which looks really tempting and beautiful, which is called Felice, which sort of gets away with some of the rough corners from Fable Reaction. So we might use that. Fable Reaction is almost identical to the stuff that you did in Oblig 1. So it's going to be very familiar to you. Felice is slightly different, but just a tiny little bit, not much. All right, so that was that for today. Yeah, until the next lecture. That's going to be really useful stuff. Bye.